a Portland Community College mathematics course, a course in arithmetic review, produced at the Portland Community College. This lesson continues to develop a vocabulary which will be used in later lessons to explain what would otherwise seem to be complicated processes. Here you have the place value name of a number, 45,632. Now let's ask ourselves, what does a 4 in this place really mean? I really don't have a 4. What I have is a 4 times its place value of that spot, which is 10,000. And in addition, literally in addition, I have a 5 times, but the 5 is in the 1,000s position, and in addition to that I have a 6 times, it's in the 100s place position, and in addition to that I have a 3 tens, 3 times 10, and in addition to that I have 2 ones. This way of looking at it forces us to look at the individual pieces, pretty much as though if you were repairing a carburetor or souping it up, you'd have to tear it apart and look at the pieces, which is what we're doing here. We could have shortcutted this a little bit by writing this 4 times 10,000 as 40,000, which is what the 4 means by being in this position. And this 5 times 1,000 is 5,000. And see, by placing the 5 in the thousands position, it ceases to be 5 and it becomes 5,000. This 6, by virtue of its position, has become 600. This 3, by being in the tens position, has become 30, and the 2 has become still 2. This way of expressing a number we call the expanded form of that place value name. Sometimes, rather than writing it in numeral form, we'll write it in word form and get this. This is just another way of saying with words what we are saying here with place value notation. So in future lessons, as we need to look at the parts of a number, this is one of the ways we will choose to do it. And this will help us to stress the value that a digit gets by occupying a certain position. This lesson also wishes to introduce you to new symbols which are used to denote the relationship between two numbers. You're already used to this in the case of the equal symbol, which tells us that this expression and this expression stand for the same number. But often you have two expressions which don't stand for the same number. So for those cases we need a new symbol. 135 is greater than the number 80, and that's what this symbol will mean, greater than. And 2 is a lesser number than 5, so this symbol will mean less than. Greater than, and a convenient way of remembering that is that this spread is greater than this spread. So this is a greater number than that. And this symbol means less than. And this spread is less than this spread. Some instructors like to tell their students that the point points to the smaller number, and that allows you to remember it rather nicely. A device which will be used frequently to explain how numbers relate and work together is to array the numbers on a line going from the smaller progressively towards the larger. When we show numbers in this manner, we'll refer to this as a number line. Now, as a definition on the number line, any number to the left of another number, by definition now, will be the smaller number, even if we don't know what it is. So in this case, if A stands for any number, and B stands for any other number, and all that we know about them is that this is to the left of that on the number line, then by agreement, this will be less than that. If the number A is less than the number B, then of course the number B is greater than the number A. So we can say it this way. This number line will be a very convenient device when you have completed this course and begin to move into algebra. You're going to see us begin to use letters to stand for numbers quite frequently, which seems to frighten a beginning algebra student until they realize they're not really letters, they're just marks on a piece of paper which mean the phrase some number and nothing else. For instance, we could use the letter R to stand for rate, and of course that's a number once you measure it. We could use V to stand for the number measure of velocity. We could use capital A or little a for area. We could use A for amount. What will be important is to realize they're simply marks to stand for the phrase some number. So if I use a capital A, that will be as different in my use as from a small a as a B or an M is. So don't confuse these. In algebra and in arithmetic, these are two entirely different marks when referring to some number. And the last point this lesson wishes to address is to come to grips with how to round off. This symbol we'll use frequently throughout these tapes, and it simply means approximately equal to. Some books, rather than using the double squiggles, will use an equal sign with a dot above it. In either cases, they mean approximately equal to. Now, if I were to say that my city has 387,256 people, by the time you are watching this tape, this number has changed. As a matter of fact, our population is changing every single minute. It'll change in groups of 10 every single day, in hundreds by the week. So perhaps the only number that will remain stable over several years is up here in the 10,000s position. So we perhaps would like to have this number just rounded to that stable position at the nearest 10,000, or let's say the state population to the nearest 10,000. So let's come to grips now with the round-off rules we will use throughout this course. So let's add to our formal notes the rules of round-off as we will use them. The first step is to determine the place at which you need to or wish to round off. In the text exercise, this will simply be given to you. In our case, we were asked to round to the nearest 10,000th position, to the nearest 10,000th position. See, ones, tens, hundreds, thousands, 10,000th. Next, look to just that one digit to its right. Look to that one digit to its right. All the others have nothing to do with it. So don't consider them at all at this stage, just that one digit. Up to this point, the amount that we're going to keep, starting from the front, working back to the place at which we wish to round. Now looking at the digit to its immediate right, If it is 5 or more, round up. That is, add 1. In this case, the digit immediately to the right of the round off position is 5 or more, so I will round this up, which means that this 8 gets changed to 9. Now, in this position down here, the digit immediately to the right of the round off position is not 5 or more. So in that case, if 4 or more or less, and by rounding down will mean leave it as it is. This digit is 4 or less, so I leave that as it is. Then replace all digits to the right by zeros. So these digits here are replaced by zeros. These digits here are replaced by zeros, so that we can now say the number 12,354,958 is approximately equal to 12,350,000. See, we need those zeros to keep the magnitude of the number, because if they weren't there, this number for sure is nowhere close to being approximately equal to that. Same thing here. The number 387,256 is approximately equal to 390,000. Now, we use approximations almost every day. When you give the population of your city, you're approximating it. When you give the distance from the Earth to the Sun, 92,800,000, that's merely an approximation, in this case rounded to the nearest 100,000. These are the round-off rules used most frequently in this and most courses you'll take. There are other kinds of round-off rules in some more advanced courses of study. These are the ones, however, used most frequently, especially with calculators. So it's important that you learn them as quickly as possible. Quickly, let's review them. Determine the place at which you wish to round off. Look to just that one digit to its right. If it is 5 or more, round up. If it's 4 or less, round down. Then replace all digits to the right of that round off position by zeros. It's very important that you learn and use these rules as soon as possible. Let's relate that to calculators. Now and then, later in the course, we will be using calculators, and it's important to realize that some calculators round off naturally, that is built right into the calculators, and other calculators do not. So if you use a calculator, let's check it now to see if it rounds off or not. Let's take a peek ahead to something we hope you know, and that is conversion of fractions to decimals, which simply means 2 divided by 3. And if you were to do this by hand without the calculator, you would get 0.666, and these sixes go on forever. Now, in later chapters, we're going to look at this in more detail. So we're actually peeking ahead to something that we will study later. But let's assume we can do that for a moment. And since this is a review course, we presume that you do in fact know this. We just perhaps need to review. We will assume it just for a minute here. No matter where you quit, the digit before it is 5 or more. So if we wanted to round here, since this is 5 or more, we would add 1 to this and make it 7. So where we quit, if we rounded, we would round up to 7. So let's check that with your calculator. Let's, on the calculator, punch a 2, then punch a division, then punch a 3, and see what we get. See if we get a string of 6s, or see if on the end of our calculator we get a 7. If we get 6s all the way to the end, that means the calculator is not going to round. If we get a 7, that tells us that that particular calculator is going to round off by these rules. I'm going to use that idea to check these two calculators to see if either or of them rounds off. So on this small, inexpensive 4-function calculator, I'll punch 2, divide by 3 equals, and you see it has 0.666 all the way to the end. If this were rounding at this position, they should have rounded this to a 7. So this calculator does not round off at the last indicated place. This calculator, let's see, 2 divide by 3 equals, and see it has 0.666667. So this is a calculator that I know that the last digit is possibly a rounded digit. So now as I use this calculator, I'll remember this one doesn't round. This one does. You might wish to check your calculator. During this lesson, we will concentrate on rounding whole numbers, not decimals. Let's say you're buying a second-hand car and the price tag is $4,325. See, here's the place value name, and what you heard me say, 4,325 is the word name, hence our last lesson. If we wanted to round it to the nearest hundred, our first chore is to find the hundreds place. So here's units, tens, hundreds. Look only at the digit just before it and ask, is this 5 or more? The answer is no. Then I leave this hundreds digit alone, everything in front of it alone, and everything behind it I turn to 0. So if somebody were to say, how much are you paying for that car? You would say about $4,300. And that's, in fact, the way we communicate, isn't it? Usually we don't tell them the price right down to the nearest dollar. We give it to the nearest hundred because that's sort of where the money becomes rather important to us. Another car might be priced at $3,289. And if we wish to round that to the nearest hundred, again we find the nearest hundreds position, units, tens, hundred. Look at the one just before it. It is 5 or more, so we'll add 1 to this digit, making it 3, leaving the ones in front of it alone, and the ones behind it we again replace by 0. So we'd say this car cost approximately $3,300 or $3,300. And you can see that this number is really closer to $3,300 than it is $3,200. After all, $89 is almost the next 100, not the one down. So you see this rounding off begins to make sense. Where you have to be careful with round off is those situations where you might be tempted not to follow this simple rule. That is, determine where you want to round. If this is 4 or more, leave these alone and replace these by 0. If, on the other hand, the place before where you want to round is 5 or more, you add 1 to this, leave these alone, and below that, again, you replace by 0. Consider this rather strange situation. We have been given the number 1,999,875, and we desire to round it to the nearest 1,000. So there is my unit, 10, 100, 1,000. So we wish to round here. We look at the digit just to its right, which is 5 or more, so we wish to round, add 1 to this digit, and these will be replaced by zeros. But see, if I add 1 to 9, that forces me to get 10, which is 0, carry the 1. But that forces me to another 10, which is 0, carry the 1. That forces me to another 10, which is 0, carry the 1. So to the nearest 1,000, this number is approximately equal to 2 million. So these zeros were placeholder zeros acquired by rounding these up. These were zeros which simply occurred because of the computation. One of the difficulties of rounding off is if you just saw this number, you can't tell by looking at the number whether it was rounded here, 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 or here. All you know is the number is close to 2 million. Somebody would have to verbally tell you that that's the number to the nearest 1,000. So if the digit to the right of where you wish to round is 5 or more, you add 1 to this always and simply let the chips fall as they will, so to speak. So be very careful when you see numbers like this. And also never forget to replace the numbers at which you're rounding, below which you're rounding, by placeholder zeros. Otherwise, you're saying that this number is close to 2,000, and that's patently a false statement. So what you finish with must be close to, that's what this symbol says, to the number you started with. If that isn't so, then you know you have made a mistake in digit replacement by placeholder zeros. So be cautious of that idea. Before we leave each other, let's review several other ideas that were important to this lesson. Let's say we have two sheets, a green and an orange one, each covering a number. We won't let you see the number, but we do tell you this is true about the two numbers. Then even though we don't know what they are, what can we say about this one relative to this one? Or in short, what does this mark say? And this mark says that this number is less than this number. So this number could have perhaps been 25. Then whatever this number is, if this is less than it, then this number must be greater than that, say 31. So you'll have many problems in your lesson giving you statements like this, asking you, is this a true statement or not? So this is saying 25, new symbol, less than 31, yes, that's true. Is this statement true? Well, let's read it. 459, and now it's just a matter of this is the greater spread than this, so we're asking, is 459 greater than 1008? And of course the answer is no. So this part of our lesson is simply to get used to this symbol which reads greater than, and this symbol which reads less than. Backing off one more step in this particular lesson lets us not forget what we mean by the phrase expanded form. And that's to write the value of each digit by itself. So this digit, because it's in the thousands place, is now worth not 5, but 5,000. And in mathematics translates to plus. This 3, because it's in the hundreds place, is now worth 300. And 8 is in the tens place, so it's now worth 80. And 6. Some people want to look upon it in this form. Others will actually want to emphasize the thousands, hundreds, tens, etc. So they might say 5 1,000s, 3 100s, 8 10s, and 6 1s. We will refer to each of them as expanded form. So if we ask for expanded form, give us either this or this. Both will be acceptable as a meaning to this phrase. Let's turn that question around and ask ourselves what the place value name is for this expanded form. So if we were to concentrate on places, we have first the ones place, tens, hundreds, 1,000, 10,000, 100,000, 1 million, etc. So this says I have 8 ones, 7 hundreds, but here's my hundreds place, and 5 10,000s. So here's my 1,000, 10,000, and I have 5 of those. And of course, these in-between spots we have to fill with a placeholder 0 so we won't lose track of our sizeness, which we call magnitude. So now reading this, we have 50,701. Expanded form, place value form, or if you will, place value name, and word name. Same number, just expressed 3 different ways. Whichever one will be used, well, that will depend upon what we're going to be doing. And in the future, you will know from the context of the situation which form we need. Sound like a bunch of words? You bet. That's exactly what this and the last lesson is. Working with vocabulary, so using that very precise vocabulary, we can explain to you in the near future some rather complicated processes. But with this highly technical vocabulary, we can make the explanation somewhat simple. So play with these words and these kinds of problems, and we will use them very, very shortly. So this is your host, Bob Fennell. Until the next lesson. Good luck.